present. Yes, good morning all of you. We are going to discuss insertion sort. In our last class, we have done bubble sort. And I said that these sortings are actually the part of data structure and which is actually helpful for you for understanding that how internally systems are sorting the information. Or if you wanted to sort or arrange the information, then what are the various methods to arrange the information? Last time we have discussed the logic behind bubble sort. Today we are going to discuss the logic behind insertion sort. Now, the next thing is that what we have to understand about the insertion sort. See, we'll start with the logic part. We will always assume, means wherever we are, means whatever position we are, we will always assume that left side values are at its correct position. And from right side, whatever value I will be having, that I have to arrange with respect to the left side value. Now, what is the meaning of this? Okay, so initially when I will start assuming or I will start traversing in the list, I'll start with first index. First index means this is your 0th index. I'm writing that also, 0 index, then 1, then 2, then 3. This is 4th index. 1 second, let me write it over here. This is my 0 index, then my 1 index, 2 index, because you know the indexes, it will always start with the 0 value. So 3, 4, 5, then 6, 7, 8, 9. Eight and 9, assume that as 8 only. Okay, now see, so the very first logic is that we are assuming that 45 is at its perfect location. This is what we are assuming. So we are not going to do anything with respect to 45. I'll start applying my logic from the next value, that is from the 36. Whatever this value I'm having, this I will store it in any temporary variable. Okay, any temporary variable. So as per the book, it is given key. So in key only, I'm going to store first of all your 36 value. This is my 36 value that I'm storing over here. Okay, then after this, next thing what I'm going to do is, I'll make another variable which I will place just at i-1 position, means from here. And I will start decrementing the value of j and I'll start comparing this value with respect to my key value. Okay, because what was my assumption that 45 is at its correct position. Now I will compare it with 36. Now what do you think, where 36 should come, before 45 or after 45?
Before.
Before 45. It means if this value is smaller, I need to shift it over here. So basically now what I'm going to do, I'm going to shift all the values in the right side till the time I'm not getting the proper place for the 36. So it means for the next time what I will do, I will shift this value 45 to the next position. Okay, so ultimately for the next time, I'm just writing it over here. Ultimately for the next time, I will be having first 45, then after that 23, then again 66, because I'm not going to make any change with the other values, then 56, then after 56, then we have 78. Remember, I'm not making any change with respect to the right side values, only I'm applying my logic towards the left side value. Then 44, then 37, then 64, then 52. Okay, so what you have to understand that ultimately what I have done over here, let it be like this. Okay, so ultimately what I have done, I have shifted this 45 to the 36 place, and then whatever is my this particular value, I will shift it over here, that is at first position, because before 45 not, now I'm not having any type of value. Fine. Now again I will do the same task. Now instead of pointing I to the first position, I will point I to the 23rd position. So here is my I now. Okay, it means my key part will be, for this particular time, my key part will be 23. See, I will explain you this also. Then for the next time, you are going to explain me that where my variables will be. And j I am going to put at I minus 1 position. It means from here. And then again I'll start comparing. First I will compare 45. It is greater value, so I will shift it over here. Then I will compare 36. Again it is greater than 23. So again I'll shift this. So ultimately what I am doing, I am shifting 45 also one time and 36 also one time. So ultimately what we are going to get, 36, then we have 45, then we have remaining all the values in the same manner, 66. After 66, again you have 56, then you have 78. After 78, then 44, 37, 64, 52. Okay. And then this last value 23, we are going to shift over here. So 23 will come over here. Now you can see we are sorting the values. You can see these three values. They are arranged in the proper manner. Now where will be I for next time, for this time? Now you have to tell me where will be I?
66.
66. Very good. I will be at 66. What will be the key value? What will be the key value?
66 only.
Again same 66. And where will be j?
45.
45. Now see here, when I will compare, already this value is smaller than 66. So therefore there will be no change in this case. It means as it is, you will get your information for the next time. Okay. It means for the next time you will be having the same information. 23, then 36, then 45. Why I am explaining you all these? Because you must know that we may have any type of values. Sometimes we may require to shift all the values. Sometimes it is not compulsory to shift the values. So here if you will see, there will be no shifting at all and we will get all the values in the same manner in this type of case. Then we have 78, then 44, then 37, then 64, and then 52. I hope this is clear why no change. But now for the next iteration. Now let me know where will be I next time. Yes, any one of you. Where will be I?
56.
I will be at 56. What will be the key value?
56.
Key value will be same. That is again 56. And where will be j?
66.
66. And how many times I have to shift the j this time?
One time.
One time.
Because one time only you will see that this value is greater. So this value I will shift here. Next time when j will come here, this value is already smaller. So what I will do, at this particular position, I will insert my key value. I hope now you will understand what I'm doing. Actually what I'm doing, I'm making the place for 56. I'm shifting all the values which are greater than 56 one step ahead. And then I'm making the place for 56. And then I'm inserting 56 at its correct position. Okay. So next time it will be 23. Then after that 36. Then after that 45. Then after that 66. Then after that 56. Then after that 78, 44, 37, 64, and then 52. Is this clear to all of you?
here instead of 66, won't 56 will come in the lower line?
Yes. That changes I have not done, right? 23, then 36, then 45. Then I have done one change, that 56 I have inserted here and 66 was shifted over here. Then after that, we have remaining all values. Right side values are always same because we are sorting with respect to the left side value. Now you will understand why this name is insertion sort, because we are inserting the values at its correct position or perfect position. So therefore this is called as insertion sort. Okay, next time, see, randomly I'm explaining you. Next time value of I will be at 78 and there will be no change. The reason is because 78 is already at its correct position. And when I will be here, in that particular case, 1, 2, 3, 4, up to 45, all the values will be shifted one time. And then we will make the place for 45, for 44. And then this 44 we will adjust over here. Is this is clear or should I explain more iterations? Anyone, any idea, any doubt? Should I explain more?
Yes,
No, ma'am.
ma'am.
Okay, fine. I'll explain more. Fine. 2 more steps I will explain so that you will understand. See, next time I will be at 78. And my key value will be also 78. So what you have to understand that in this particular case, my J is at this particular place. So if you will see over here, there will be no change. The reason is because 66 is already smaller than 78. So there will be no change. So it means you will get the same array, same list in this case. So again, my list will be 23, then 36, then 45, after that 56, then 66. After 66, then we have over here 78. After 78, then we have 44, then 37, 64 and 52. Now see, try to understand because now this time we will be having good shifting and good swapping. Now next time I will be at 44th position. Okay, wherever is my I, that will be only my key value. So my key value will be 44. Now this time J I will keep at I minus 1 position. It means at this position. Okay, I'll compare J. This is greater. I will shift this over here. Then J minus minus J will be here. This is also greater than 44. So this I will shift here. Okay, all values, all greater values I will shift one by one. This is also greater. So this also I will shift here. Means 56 will come here. Then I will be here. Then 45 is also greater than 44. So this also I will shift over here. Then J will come here. This time this value is smaller. So whenever the value is at smaller place, then at J plus 1 means at this particular position, I'm going to insert my key value, that is 44. 44 I will insert over here. Anyone, any doubt? So ultimately what I will be getting, now you can see my list will be 23, then 36. Now we will be having 44. Means 44 we have inserted at its correct position. And remember, insertion sort is considered as much more better as compared to that of your bubble sort and other sorting. The reason is because number of loops and comparisons are less in this case as compared to others. Then 78 will come here. Then 44 has already gone that place, 37, 64, and then 52. I hope now this is very much clear to all of you. Now let me know if you have any doubt. Hansi. Yes, Twinkle, any doubt?
No, ma'am, it's clear.
Okay. So we will discuss the coding part now. Because see, once the logic is clear, then there is no problem to understand coding. Otherwise, coding will become very complicated. The biggest problem will be why we are shifting. That will be the biggest problem. Okay. See, the very first thing is we are going to make the list. So n is equal to, we are going to ask from the user int input, enter limit. Enter limit means the last particular value. Then that many values we have to ask from the user. My list is empty. Then for I in range, and that too up to n values, user will give me the values. So values will be equal to again int and input, and then enter values. This value I need to append with my L dot append with my list. So this is only the logic for creating, or basically we can say that for taking input for the list. Okay, once this is done, then we need to run the loop. Loop has to be very much clear to you. For I in range. Now the value of I, I'll switch over again and again so that we should correlate, we should be able to correlate it with the starting with our logic. Now see, you will see from the very first time what we have done, we started I with first position. The reason was because what we have assumed that 45 is at its correct location. So I will always start with 1, and we will compare, we will go up to 9th position. Why 9th position? Because it is not compulsory that 52 is also at its correct position. Maybe we have to shift this also, right? So value of I will vary from first till n minus 1. This is the first thing that you have to keep in your mind. So therefore, when we will talk about this, so we will start this with 1. Then as I said, up to n minus 1. So length of your list. Length of your list is 10. So 10 will be excluded. So it is 1 to 9. Okay, once this is clear, then every time the key value will be the value at ith position. So list of ith position value. Okay, this again we are checking. See, you can see every time what I was doing. If I was at this index, then 36. 36 means list of ith index. Similarly, next time also. Next time when I was at 23, means this index number. So 23 was my key value. So whatever index number was there in the I, that same value was stored in key. And when we talk about J, I'm explaining you that logic also. J, we are always starting from I minus 1 location. Now there will be 2 conditions. The very first thing is till the time we are getting greater values, or another thing is till the time we are reaching to the 0th position. Okay, the reason is because, for example, if you will see this condition only. So here 45 was also greater, 36 was also greater. Now if your J will come at minus 1, then it is of no use. So till the time J is at 0, then only we will do the shifting. Okay, because what we have to understand, ultimately this value was smallest value. So this has to be at the 0th index only. Okay, so ultimately there will be 2 conditions in this particular case. So this logic is clear that whatever is the index of I at that particular place, whatever is my value will be stored in the key. Now we have to run the loop for J. So here we can use while loop till the time, the very first condition is J is greater than or equal to 0, because 0 is the smallest value, fine. And we have one more thing, and till the time my key value is smaller than list of J, or you can say or you can say that list of j is having greater value. It is your choice how you are writing. Till that time, what we have to do? We have to do the shifting part. How to do shifting part? Now again we have to see over here. If you will understand the shifting, how shifting we were doing. Suppose if I was here, if j is at this position, so j plus 1, value of j we are storing at j plus 1. Over here also, value of j we are storing at j plus 1. So in j plus 1 we are storing jth position. Fine. So therefore, in j plus 1 we are storing. So we will be writing something like this, that at j plus 1 position we are storing jth value. This is also clear? And then j we have to decrement. So j is equal to j minus 1, because we have to keep on decrementing the value of j. Then once this is over, then we have to, once this is over, means once the shiftings are over, you can see over here, for example, in this case, this particular case, once the shifting are over, j will be at this position 36. So at j plus 1, we have to store this key part. Okay. So once the while loop is over, then at j plus 1, we have to store. So once this while loop is over, at j plus 1, L of j plus 1 is equal
Excuse me, ma'am.
to key part. Hanji.
Ma'am, we have not defined the J.
You have j value we have to give, that will be at I minus 1 position. Here only we have to give. J is always at I minus 1 position. And from there only we are starting.
Okay, ma'am.
Print sorted list is. See, the program is too easy, very small. But at least we should know the reason, or plus we should know how the iterations are going on. Sorted list is, and then you have to print the value of your list. We will execute and we'll check this. Enter limit 5, 66, 45, 34, 12, 89. You can see we are getting the sorted list. Fine. One more thing. Just suppose you wanted to see all the iterations. Sometimes we wanted to see all the iterations. Then in the loop only we can display our list. How we can display the list? Once the here only we can print the value of the list. List at then the value will be value of ith iteration. And the value of L. Now if I will execute this, enter limit, suppose 6, 45, 34, 67, 23, 12 and 33. Now you can see over here, I have given this list. Very first time it was assuming that 45, this is what it has given. This is my list actually. Okay. So very first time you will see only this 34 has been swapped with 45. The reason is we started from here. So only these two are exchanged basically. Remaining all the values are same. Next time I will be at this position 67. So there will be no change because 67 is already greater value. Next time 23. Now when you will compare 23, it will come in the first. So all these values 34, 45, 67 has shifted one time and 23 has come over here. And then next time 12 we will take. For 12 what they have done? All these values has been shifted one place. 23, 34, 45, 67 and 12 has shifted to this. And in the last time 33 was there. So 33 was supposed to be between 23 and 34. So you can see only these 4 values they have shifted, and then 33 they have placed over here. Means basically what we are doing, we are making the place for the value which is at ith position. Now let me know if you have any doubt. Any doubt with the output screen or any doubt with the coding part? Any doubt?
No, ma'am.
Okay. Okay, then today you have to revise this, and we have completed our syllabus for our annual examination. Okay, from next time we will do revision part, but you have to let me know that whatever topics you are not clear with. Doesn't mean that this complete chapter. You have to give me the topics, and then we will discuss those topics. Okay, then good day all of you, and do this practice. Try to do this without seeing from the book. Okay, then.
Excuse me, ma'am.
Yes.
Ma'am, the topics which we need to revise, we need to message you.
Yes. Okay.
Okay, ma'am.
Come to know, so I will be discussing those topics only. Okay, then good day all of you.
Have a nice day, ma'am.
Good day,
Good day, ma'am.
Good day, beta.